Hey guys, Mr. Ruiz here for your third day of the 2.3 note. So now that we know the product rule and the quotient rule, we're going to still use those. We're going to combine those together. But we also want to make sure we can still take the derivative of things that are out there. So there's other trig functions we haven't worked with. We have sine and cosine, which I've kind of told you are going to be the two that I'm going to make you memorize. The other ones that are out there, tan, secant, cotangent, cosecant, I'm still going to let you guys I still want you guys to be able to take the derivative of them. I just don't think you guys need to memorize those. So if I ever give you those in a problem, I would always have you guys look back at this, or I'd give you guys these. So these are basically the rules here. So the derivative of tan is secant squared. The derivative of secant is secant times the tangent. The derivative of cotangent is negative cosecant squared, and the derivative of cosecant is negative cosecant times the cotangent. So those ones are not as easy to memorize. But if we have those up here, we can still go ahead and take the derivative of that. So let's go through C here, and let's take the derivative of them. So I need my drawing tools out here. Let's do that. I got my drawing tools. Let's go. All right, so what's the derivative of x minus tangent of x? Well, that would just be y prime would be the derivative of x is 1. The derivative of tangent is secant squared. So it's 1 minus secant squared of x. There might be some trig identity to simplify that down, but that's good with me. Okay, the only thing that you'd have to watch out for is if it's being multiplied or divided, which we have in part B here. So if we have x times secant squared, we have to do the product rule because that's x times. So the derivative of x is 1. We'll leave the secant alone. And then plus, now we'll leave the x alone. The derivative of secant is up here is secant x tan of x. So the only thing we could do here is factor out a secant, and we'd get 1 plus x tangent of x. And there's the derivative. Okay. So next what we're going to be doing, and it's going to take us some time here, is combining the product rule and the quotient rule together. All righty, so let's go through this one here. This is getting crazy. We'll do this problem together, then we'll take a look at tonight's CYU. Okay. So let's see. What we need to do here, long drawing out, is look at, we have two things that are being divided, so we have to do the quotient rule. So we're going to have to do low d high minus high d low. So let's start it off, f prime of x. If I have low, which is x minus 1, and then d high, when we get to the derivative of the top, this is x, 3x times sine of x. We're going to have to do the product rule. So the product rule is going to go inside of this quotient rule. So we have low. Now the derivative of the high is, just isolate this part here. We have 3x, which is 3. We'll leave the sine x alone, plus the 3x is left alone. The derivative of sine x is cosine of x. So far, this is just low, and that's d high. Then we're going to have minus high, and then times d low, which luckily for us, d low is just 1, all over low, which will put x minus 1 squared. Okay, so what does that mean we have as an answer? Well, we can distribute the x, and we can distribute the negative 1. So we're going to have this super long equation here, and it's all over x minus 1 squared, all over low. So let's distribute the x. This would be a 3x sine of x plus a 3x squared cosine of x. Then we'll distribute the minus 1. We'll have a minus 3 sine of x and minus 3x cosine of x. And then we have to distribute the 1 to here, so then we just have a minus 3x sine of x. All right, what's left over after all this mumbo jumbo? Well, let's see. We can get rid of this 3x sine of x and this minus 3 sine of x. That goes away, and these are all just left over, and that's all we can do with that. So the answer here, the derivative would be 3x squared cosine of x minus 3 sine of x minus 3x cosine of x. And this is all over x minus 1 squared. Now we could factor out a 3 from the top, and both of these ones here have an x and a cosine x, but that doesn't have an x or a so all these just kind of like, you can factor out 3, that's all they have, and other than that, there's not much we can do with it. All right, so let's take a look at the CYU that you guys will have to work on tonight, see if we would have any problems that we can give you some clues on. So what we'll be doing for the next couple days is just practicing our skills, making sure we have this down pat before we start applying this. So CYU 3, let's see, we find the derivative. This one, 26 is just straight low D high minus high D low, nothing crazy there. All right, this problem here, 30, is just product rule. Now you might want to rewrite this to x to the 1/3 power times x to the 1/2 plus 3. That's going to be easier to go through. Now, if you wanted to just FOIL this out and take the derivative the normal way, that's totally fine. You get the same answer. All right, 34. What is going on here? So we have x squared times 2 over x minus. Okay, so if we look at this, we would have the product rule, and then inside the product rule, we have 2 quotient rules. So remember, just like this problem here, we could simplify it before we take the derivative. We could probably do the same thing here. So off to the side, I'm going to write out what g of x could be. If I distribute the x squared, that is a 2x squared over x minus an x squared over x plus 1. All right, now if you look at this, we have just, you can leave this as just like 2x. There's a couple different things we can do here. We could change this to a 2x minus x squared over x minus 1 or x plus 1, meaning, okay, that's an easy derivative. And this one here, you just have to do a pretty easy quotient rule. Now, if we wanted to combine these together, let's see, we would have to get a common denominator of like x plus 1. So I'd have to multiply this by x plus 1 over x plus 1. And we would get a, let's see, 2x squared plus 2x minus x squared over x plus 1. And so this equation would come out to be an x squared plus 2x over x plus 1. Okay, so just kind of going back to what I just did there. If you want to, I mean, there's a lot of different things you can do here. You can start off this problem by doing product rule with the quotient rule in it. But I distribute this here, so then I have 2 separate quotient rules. Or since 2x squared over x just is 2x, you can leave this as a simple power rule minus 1 quotient rule. Or we can combine like terms, and now we just have a problem that we can just do 1 quotient rule with. So either one of these starts wherever you want to start with, we'll get the same derivative. I would probably recommend this one here because that's just 1 quotient rule that will just simplify it down at the end. Alrighty. 36 here, if we look at that, you just have a 3 times product rule. So derivative of this, leave those alone, derivative of this, leave those alone, derivative of this, leave those alone, combine like terms at the end. The only problem there is probably your paper might not be large enough to do all that work. Alrighty, and this one here, trig functions, should be fine. I don't see anything too crazy that you guys need to worry about. They're all just sines and cosines, which those are the ones I expect you guys to memorize. So if you guys have any questions, reach out. But right now, for the next couple of days, we are going to be practicing the product and quotient rule to make sure we understand it extremely well. All right, guys, have a great day. I will see you next time. Adios.